Thank you all for coming. My name is Matt Warger. I'm from Kansas City, Missouri. And today we're going to talk about TypeScript and GraphQL and how they can help you create rock-solid components for your applications. First, a little background, a quick one, to tell a little bit about where I got started. I started off mainly as a server-side developer doing Java. For those who aren't aware, Java is a strongly typed language. It's open source, and it was my first language introduction. You have to make types for all of your objects, and that was what I first learned. Soon after that, I moved to .NET. This is also strongly typed, and where I'm from, this is kind of the darling of the enterprise. If you work in a larger organization, you're probably at least familiar with .NET and Microsoft, the Microsoft stack. This is where I was introduced to MVC and the pattern of model view controller, where the UI you're writing is server rendered, and all of the objects you're interacting with are strongly typed, so you know what they are while you're writing your app. Moving ahead, I started to get introduced to the experience of writing with front end. And it started off with jQuery. I'm sure many people are familiar with jQuery, like it or hate it, but that was where I got started, sprinkling little bits of JavaScript in my .NET applications. I moved on to Angular, the first one, where I was introduced to the same sort of bits I was used to in the MVC world, but this time all as a single-page application. From there, I touched on a little bit of Knockout. Knockout is a templating language for allowing you to write bits of components that can show data, and you can interact with those through events. This was my first real chance at writing component-based single-page applications. And then I moved on to kind of the two or bigger ones, and that was Angular, this time the second one. And that was where I really was introduced to TypeScript for the first time. I liked Angular to begin with, and I've used it a lot, and I've shipped it to production. But when I was introduced to React, that's where I really fell in love with the single-page applications, the component architecture, all of the cool, fun things you can do with a modern framework. But as I started exploring that, I was missing a bit of what I was used to before, and that is server-rendered pages where the data that you're interacting with, the things you're showing, are strongly typed, and therefore the tools are vastly helpful for letting you know that the app that you're writing is going to show up the way you expect. And I'm sure we've all seen this. Right up top there is undefined is not an object. If you've written front-end applications, you run into this, and it's kind of annoying. After a while, you start to realize that the problems you're facing kind of follow a curve. And in this example, you might have some initial qualms with what business logic you're trying to worry about, right? And so how hard the problem actually is kind of follows a curve like this. But as time continues, you realize that the problems you're facing are pretty difficult. But if it goes long enough, you realize it's not really that hard. It's probably something silly, probably something that in a modern application, a type system could help you with. And that's kind of the root of the problem that I see, where this happens in your mind, where you are going insane trying to figure out how this one error could be causing all of my problems. These same types of errors coming up again and again. So I want to talk about kind of DNA of your application. And the two main parts that we have to deal with are your app and your data. These two things commingle together, right? This is your business logic. This is your API. This is your other service calls, all of the things that you have to do day to day. And the one thing that I've found at the middle of all of this has been TypeScript. And we're going to talk about how that can help you build better applications that you can depend on. So first off, we're going to talk about why types and why TypeScript and GraphQL. So let's start with types. So why types? Like I said, it's kind of like the DNA of your application. It can describe it in ways that are helpful to you. And DNA ends up being a somewhat good analogy because it's a bunch of random characters. And if you were to look hard enough in here, you could start to pick out the patterns, but it's not that descriptive. You can start to add descriptions that you may get from other libraries, and when you start up a project, a single-page application with TypeScript, some of those libraries start to come in and give you some help. Start to describe your components, describe the things you're working with, and then you start to type things. And it really turns it into a description that is helpful for you, but as we'll discover, it's a lot more helpful for the tools you use. And you kind of get a compounding effect by using these systems together. It kind of serves as documentation for you and your machine that enables you to work better and create dependable applications. It makes your editor better. You may be using IntelliJ or VS Code or Atom, any number of editors. But when your tools can lean on these descriptions, these types, it makes everything better. So for there, let's go with why TypeScript. So I've picked TypeScript specifically. I work with it every day. I enjoy it. But that doesn't mean that I haven't looked at other options, and there are some. It's kind of a spectrum. You can head from one direction to the other. You can use just JS, vanilla JavaScript, as long as you know the types of objects you're working with, how you've described them, it works fine. You could go and use something like flow-typed. This is a way to still write JavaScript, but annotate it with types. This has been fairly popular at Facebook, where it was invented. But I found the tooling to be lacking. The community isn't all there. They're supposedly working on this, trying to make it better. But maybe that'll bear fruit at some point. At the other end of the spectrum, you have things like Elm. Elm is a front-end framework that purports to not have the ability to give you runtime errors because everything is strongly typed. Everything returns something, even if it's nothing or an error. You can look at Reason. This is probably going to, we'll probably have to rewrite all our apps in Reason in the next 6 months, right? Because that's how fast things are changing. But in the meantime, I think TypeScript provides the best balance of community, documentation. There are many popular projects that have started to adopt TypeScript because that interoperability between different libraries when everyone's using types really starts to show its merit. So what is TypeScript? So it's typed, it's in the name. This means that you can annotate sections of your code, objects or functions, variables, whatever, with types that describe what the shape of the object or the type of the variable is. And we'll look at examples of this. So it's also a superset of JavaScript. What this means is that the intention is that all JavaScript is interoperable with TypeScript. So you can write a JavaScript file, and it will work with the TypeScript tooling and compiler so that you don't have to have all TypeScript. You can still have some JavaScript sprinkled in there. And this helps because this means that this approach is incrementally adoptable. You don't have to rewrite your applications. And there's some other benefits to that we'll look at. Also, there's advanced features. So these are language features that haven't yet or can't be implemented in strict ECMAScript. Things like there are some different proposals. One of the more advanced features that we'll look at is generics. If you've worked with a strongly typed language like Java or C#, you may be used to these. But it's something that you can use in TypeScript, and we'll see an example of that in a React component. It provides some great flexibility. So, to start off, this is a basic type. So we have a name, and here we can annotate it as a string. Change my color. So this string with the colon just annotates what the type is that you expect it to be. If you were to try to assign a number to this, it would fail. It would put a little red squiggly under it. We'll see plenty of examples of those that help describe your app. So here's a game type, slightly more complex. You can annotate your objects by saying that it's going to be an object with a name and a score. So you have a string and a number. And you can keep going, right? Here's an array. We know what our game type was. It has a name and a score. And we want the array to actually be an array of game. So changing these properties, we'll know that the array will contain that. It cannot contain an array with a game and a review or whatnot, like you would be able to do otherwise. This array, you could just have it contain anything you want. Based on those types, you can also do nice tricks, and one of those is using the type of keyword. This becomes helpful once you get into wanting to take data that you're using and infer types based on the description. So in this case, you can define an object. We've defined Rocket League as a game. It has the name and the score. It has the same type as before, but we haven't declared it as that type. What we want to do in this case is infer the type based on the actual object. So we'll end up taking, TypeScript will go ahead and introspect this object and know that it's going to have a name of type string and a number. And then we can use that type to make sure that any following objects are recognized as the same, right? You basically get to declare a type, and then you can use one based on any information. This works particularly well with primitive types, like strings and numbers and whatnot. And if you get really crazy, you can start to TypeScript your CSS, which is a pretty powerful feature when you have objects that are essentially keys and values. Solves a lot of problems. So here's an example of type inference. Video's not working. Well, in this case, if you were to allow the tool to infer types, it would end up allowing you to place the actual type of the function based on the name. So you end up with type string and a number. of age. And it gets that by actually using the types of the function itself to infer that for you. And that's a benefit of the tools and how, in this particular case, VS Code can use TypeScript and the flag that we've put here as kind of we can flag it to essentially allow VS Code to know, I want to look in there and figure out what the types are for me. And this is nice because this is under a quick action in VS Code, so you can get away with not having to type as much. So this also provides inline documentation. So in this case, video's not working. In this case, if you have a third-party library, the ability of TypeScript to provide types either for your components or other components would allow you to view documentation that's either pulled in through the VS Code editor or the other components that you have where you've already declared types. So then you also have autocorrection suggestion. In this case, TypeScript has decided that it thinks I have an error, and indeed I do. I've spelled children incorrectly. And it's going to pop up a little light bulb that will let me autocorrect the name and spot common errors, because it's looking into the code that I'm writing, my components, and providing me help. And then renaming across files. Apologize, the media's not working. In this case, something that you can do with TypeScript that you cannot do in normal JavaScript is that once it knows about the modules that you have and the files you have, you can refactor in a way that you can't accomplish with JavaScript. If you rename this custom button props to something else, it's going to change it here, and it'll actually change it over here in a completely different file and mark it all across all of the different files and any actual reference, because it's not just a smart find and replace. It actually knows specifically what modules you're working with. And that's something that you get with TypeScript that is actually not possible currently with regular JavaScript. So if you use VS Code, you may have seen this hovering at the bottom when you boot it up. And this is the JavaScript and TypeScript language service. So if you're writing JavaScript, you may experience some of these benefits simply by using a smart editor like VS Code. This is super helpful. If you don't have TypeScript in a project yet, you can still get a little help. You can put in that TS check flag in some of your JavaScript files if you'd like, and provide a little more help. Now, you don't get as much as if you were to use TypeScript specifically, but it can be part of your migration strategy if you're starting to adopt it. So let's look at generics. At the risk of going too much in the weeds, we're going to cover this because I find it a really powerful way to provide flexible components, but then type them and make them specific to what you want when you need to. So we'll look at an example. In this case, imagine that we have a list of games. And imagine that we have a component here that is a header. Pretend you provided a list, and when you click on this, it sorts it based on some key. In this case, we have a games array. We have a function that we've passed to it, and then we have the sort key. So this, in React, is declared as a component, and at this point, we have all of those props that we passed in, but we also have this. This is just a convention. T can stand for whatever you want. It is the type that we've passed in. So in this case, we have game. And we can tell the component, the sort header, of the type that we're expecting. And all of these types can relate to one another. You can kind of pass them around almost like variables and reference them. So we know that this T is going to go here, and we say that it's a game, so this list, those things will match up, and this will ensure that when we use this sort header and we tell it the type is game, that the list that we provide to it is enforced that it must be a list of games. In the same way, the sort function will be enforced as a function that can operate on games. The sort key has to be a property, a key of game. So if a game has a name and a score, you can't attempt to use ID as the sort key. TypeScript will prevent you from doing this, and your code will not compile when you use this. In the same way, we can take that same type, pass it here, and we can pass it to another object. You can keep kind of chaining these along to guarantee that the functions and keys that you're operating on, the different variables, are all interrelated in the correct way. So you can have a completely generic sort header that can operate on any object you want, but you know that all of the little bits that you're interrelating with, like this sort function, are going to work. In this case, you've told it that even this function is going to take a list of games and a key that has to be a part game, and it's going to return an array of games. So here's the real question. How do you get started? Now, all of the major JavaScript food groups currently have some variation of TypeScript support. Vue CLI has it in the built in. You pick it on optional when you start up a new project. Angular, for those who use Angular, already know that it's kind of built in. They started it that way. It was a good decision on their part, in my opinion. React just launched support in Create React App for providing TypeScript support. And at least in that case, you name a JS file to TSX and you're done. It's pretty nice. The way the tool ecosystem has improved over the past number of months has been really impressive. So that's kind of your app, right? We've kind of handled your app, your local state, your props. You can type all of that stuff using TypeScript. But then it gets to your data. And these things need to be able to communicate with one another. And you need to be able to use your data in a dependable way. And it would be nice if you could do that with TypeScript. Luckily, you can. And that starts with GraphQL. So why GraphQL? Let's start with what first. Straight off the website, this is a great description. It's a query language for your API. It's a runtime for fulfilling those queries with your existing data. That means it's adaptable. That means you can use data sources you already have. GraphQL provides a complete and understandable description of the data in your API. That's based on the schema that we write to tell our API what our types are. It gives the clients the power to ask for exactly what they need and nothing more. This solves the problem of overfetching and underfetching. If you've researched GraphQL at all. By the way, who has used GraphQL? A couple people? Who's heard of GraphQL? Okay, a lot more people. That's good. Overfetching and underfetching are a couple big ones. Underfetching refers to the term where you have to go back to the server for more information. You might get a list of things in a master detail view, for example, and once you have each of the items IDs. Maybe you have to go back to the server and request a certain set of data for each ID. It creates a lot of requests and makes your app really chatty over the network. Overfetching is the problem where you may have a RESTful endpoint that returns a certain set of data, but that particular view in your app only needs a little bit of it, right? So you essentially are sending extra data, you're overfetching, and you throw half of it away when it gets to the client. This costs users data and is, hopefully avoidable, and it is with GraphQL. It's one of the strong bits of it. It makes it easier to evolve APIs over the time. That's also a great feature. It enables powerful developer tools. Now, this is all awesome, and to talk through all of this would literally take a day in any amount of detail. And that's why we're not going to do that. I don't really care about any of this right now. The developer tools part is what really interests me. I really think they kind of bury the lead by putting it at the end there. I think it's probably the most important aspect of the spec and the tools that come with using GraphQL. So here's some basic types. Like we looked at basic TypeScript types, we'll look at basic GraphQL types. Actually start at the bottom with query. Query can get game, can get popular games. You can pass arguments to this. You can return game in brackets. Any guess to what the brackets mean? It's an array. Yes. So this game refers to the game that we just declared here. It's got an ID, name, URL, summary. It's got a cover, which is an image. And that refers to this guy up here. It also has some properties. These can relate to each other. They can be composed inside of each other, just like TypeScript types. When you start working with this, you start running queries. So queries are how you fetch data. We're not going to go into necessarily how that data is gotten. It could be a service, it could be a database, another API, another RESTful API, another GraphQL API. It doesn't matter. But when you do, you end up structuring an object that you send over HTTP, and it looks like this. In this case, I am calling that same getGame query. I'm saying I want to get a certain ID, and I want to get these properties out of it. And that turns into this. So the nice part is that the shape of the data is the same. If you notice, there's an analogous structure to my game and my game, an ID and name and summary. This cover, an image, is nested, just like this structure here. So this is the way where your data can be predictable and dependable. So when you look at the types, you can end up with types that you can use in your application. And so these follow the same structure. Now, this is TypeScript that is based off the same types in GraphQL. And that's pretty powerful because now the data you're fetching in your app can be used and interpreted by the same tools that you're already using to develop your app in TypeScript. But what if your schema gets larger? Now, it starts up at that end and overlaps a bit, but as you start adding different bits to your game, and by the way, this is the Internet Games Database API adapted to GraphQL. As you start adding reviews, achievements, platforms, you start adding more types. And it would be pretty frustrating to have to worry about all those types as part of your development workflow. You can end up with queries that are fairly long or not quite as long. But the different variations that you have to deal with can be problematic when you start to develop any sort of real-world application that goes beyond a simple demo. So tooling is another win here, right? And the types that you use enable different tools along the way. We've looked at the editor. And over time, these queries and mutations and other operations you do with GraphQL, the types you're using, those will change. And having to update the types all the time would probably be frustrating. Luckily, there's tools for that too. So what does that look like? Looks like this. These are 3 examples of how to generate types from your GraphQL schema. This is what really clicked for me when I realized that I can have that same dependability that I kind of missed from .NET land with all of the fun of using TypeScript and React. The top one is probably the most popular. This is Apollo. They have a whole suite of tools. They have an environment that you can host GraphQL implementations. They have a server library for multiple languages. They have client libraries. It's fantastic. Amplify is also great. I've actually shipped a product with this, and it's fantastic. GraphQL Gen is a relatively new one. It's kind of not related to any big organization. So if you're kind of indie, I guess you could go with that one. They all accomplish the same thing, though, and that is to take the schema and queries that you're using to operate on your data and generate types that you can use in your application. And the workflow is essentially you have a GraphQL file, you run whatever the generate command is. Some of them have a watch mode, so you don't have to keep running it. You can just let it sit there. And it's going to generate TypeScript files for you. If you want to use Flow, it can generate Flow for you. I wouldn't recommend it. Use TypeScript. And over, that's kind of the workflow. It ends up being pretty simple, but what the tools make for you is pretty powerful. So remember, we have these 2 queries, and the great thing about GraphQL, obviously, when we talked about the bit about the over and under fetching, is that you can have large queries that return a lot of data. So it ends up looking like this once it's all generated. And I don't know about you, but I do not want to write that. So generating it is awesome. You will know, based on your schema and all of the types involved, what the shape of your objects are, whether things are null. I mean, that's probably like 80% of it right there, just to know if something's not going to exist. All the problems, millions of dollars wasted when that happens. These things nest inside of one another. They all reference each other. Kind of big one down here on the end. It's the get game. So what does that look like? Well, here's an example of doing a query using Apollo in a React component. So we've used our query here. We have the data that comes back and a loading. So just as basics, right? If loading's there, we'll just load, and then once that's not loading anymore, we'll have our data. So when we reference this, you know that data.mygame.reviews is there, and for the sake of simplicity, we're just going to spit it out on the page. And that's great. That works fairly well. But if you notice, we aren't actually referencing any types here. We want to make sure that our data access is safe. So at this point, you've probably done something like this, which is kind of stepping through the nested objects. And this is necessary, obviously, because depending on how you work with the schema, nested stuff is totally cool. It's going to happen because that's the nature of GraphQL. But do we know if this is right? Turns out, if anyone can spot the difference way up there at the top, nice thing about TypeScript, especially when using it with JSX, is that many libraries have started to provide generic implementations. So in the same way we looked at generics before, and we know that we can pass in types to other components, that way the component can be smart about what it returns to us. In this case, Apollo is returning this data, and we suddenly have a red squiggle under our reviews. So something we're doing here isn't quite right, because the only thing we did was add this get games at the top. Now remember that kind of down here at the bottom is get game. So it's going to look at the game that we typed for our query, that get game interface, and it's going to know the shape that's going to happen when we actually start to access our data. And when we look over at reviews, it says that it's possibly null or undefined. And it knows this because it's looked at the type. VS Code is very, very good with introspecting, and it's very fast when working with TypeScript. I've been very impressed with the little amount of overhead that's actually occurred or that I've noticed when dealing with this. So what this allows us to do is notice when we're possibly going to be shipping something that can break. And that's the big thing. So a couple tools and tips related to this. When you start messing with nested data, I found this utility to be super powerful, and you can see the example of it right here. You import this, and this is based on the optional chaining operator. I believe Groovy has this. Some other languages have something like it. It basically allows safe access of nested objects. So in this case, you can wrap the initial one here, this data, and allow you to safely say mygame.reviews, and then you can give it a default as an empty array. So you don't have to do that logical and chaining all the way down through nested objects, but you can safely provide a default where now all you have to check is, well, is the link there? If it's true, then we want to show the reviews, otherwise no reviews. And that's also pretty great. So the next part I want to talk about is fragments. And so just like we have types composed of other types, GraphQL can do the same thing. And it's really helpful when you use a certain bit of information multiple times in your application in different places. So this reviews might be a good example, because we might want what is essentially a review, not in this list, but in a different game or in a summary view, detail view, whatever. And so we can extract these like we make more complex types in TypeScript. And in GraphQL, you call it fragment, you can give it a name, and you tell it what type it's a fragment of, in this case, on review. So that same little bit that we had there is what we use here. And now we can use it in our schema, in that case, and it will generate us a type that we can use here. And if anyone noticed, I had declared this as any. Really shouldn't do this, but for the sake of example, it's here. If you can at all avoid it, don't type your stuff as any. Use these types that are generated for you. So in that case, when we've extracted a component out, we can use this review that was generated for us by Apollo or any of the other libraries, and type a component to iterate in a list or show another bit where it knows its type in the same way that you would declare it if you had written the type yourself. So how do you get started with this? You can start by wrapping a current API. This is super helpful for taking a bite out of little sections of probably what is a current RESTful API and adopting it to TypeScript. That way, maybe if you're starting a greenfield application, I really contend that you should probably go ahead and start it as a GraphQL API. The benefits of it, I think, really outweigh any sorts of costs. I believe maybe edge caching is the only thing that you could really do with REST that you couldn't do with GraphQL. But it's truly, unless you're just an absolutely massive company, you may not really. It may be worth it. It may be totally worth it. You may not need that small bit of performance. But overall, getting these tools and how TypeScript and GraphQL can interact with each other and save you developer time is absolutely worth it, in my opinion. So, forgive the corny clip part, the point is to move the power from the third party or you, whoever and whatever data you're accessing, and move it to you in TypeScript, because regardless of if that API is under your control or not, if something changes, the objects that you've coded to in your applications will be the same. And most client libraries, including Apollo, provide for very nice error handling, where you can gracefully show errors, but your actual object structure remains intact in case that way your components do not, red box your users, because that's really what we want to avoid. At the end of the day, it's great to have tools that help us as developers, but not having something blow up in a user's face because one thing was there one day and not the next is definitely a win. So the point is to shed light on what your data looks like, right? That way you know and your tools know how they can help you. I found this interesting. This is from Rollbar. They put out a bunch of projects. They kind of do crash analytics and monitoring. This was their list of the top 10 JavaScript errors. I found this really interesting because if you notice, a lot of them are type errors. And really up at the top, quite a bit of them, and this is a lot. So if you do type your components and type your objects, we can get rid of that one and that one. Null's not an object. We can get rid of that one. Object doesn't support it. That won't happen anymore. Undefined? No. Nope. Nope. So the vast majority of the errors that you will face on a day-to-day basis, on average, will be solvable by typing your components. And the main point I'd like to make is once these tools are in place and they're all incrementally adoptable, you don't have to rewrite your whole app to use TypeScript. You don't have to rewrite your whole API to use GraphQL. You can start to bite these off in pieces and give yourself small wins until eventually your entire app is typed. So when you have types, you can generate code with them. You can generate your documentation. Your queries are based off types. You can go even so far as to generate types to our databases or vice versa. Excuse me. Your services, they can introspect your types and utilize them. You can generate code for your services. All of these things can all be interrelatable once you have an end-to-end type safety for your applications. And again, the main point is that of all the other benefits, types equal tools. And that's the most powerful bit that is really I've really enjoyed the past months learning about this and working with it. I've been able to ship products that I can go back and change and not worry. I can change my API, and the second I regenerate types, I know where it's going to break. And the most important part is once that happens, you cannot ship broken code. Your code won't compile unless you make the red squiggles go away. The red squiggles show up when anything changes that can potentially break. Your users will not get, red boxes of death showing up on their screens. It's an absolutely like mental overhead just goes away because you don't have to worry about, did I forget this thing? What is that object again? I don't remember if this API was this way. You have all of that, and your editor does too. And that's the most, it's the greatest feeling ever to have this workflow down. So here's some resources. Start at the top, obviously TypeScript, Lang, GraphQL, Apollo, it's a fantastic library and kind of whole ecosystem. Amplify, like I said earlier, I've used that extensively. It's an absolutely great tool chain. If you want to know more about that or any of these things, come talk to me after the session. I'd be more than happy to talk your ear off about it. And thank you for listening.